We have given 1,000 only, sir, right?
Oh, it is 0.2 seconds. So it is 20,000.2. It is my centiseconds. So if you can run this, I can hear some kind of sound. I don't know what you hear. Just see. Now let me make it as 10,000, right? When I execute it, I don't know whether you are getting the sound or not. Just see. Now I will change it to 5,000 and the sound is different. It is not coming at all. So now make it as 10,000. Now sound comes, right? Now we can see the sound of my sine wave. Can you hear the sound of the sine wave? Have you built your wave?
Yes, sir.
Yes, sir.
So you can hear it,
Yes.
right? What happens when this rate is 50,000,
The pitch increases.
right? It's just a beep,
Yeah.
right? The
Yes.
pitch increases, the amplitude also increases. It is like when the woman and men sing in a chorus, the woman's voice will be heard. Have you observed it? You can see that. Now, if you can make it 50,000, it is just a beep. Now you make it 20,000, how it works like. So make it 20,000 and see what is the sound. It is similar to, kind of 10,000, but actually it is better than 10,000 now, but faster than 10,000. Now, if we look at 50,000, it is fast beep, right? Similarly, make it 100,000, right? It's just beep, right? This exactly is how ECG signals, XYG signals, all those signals are working based on sample rate. Are these many samples? This sample 20,000 is only 1/5 of what I can do here. So only that much of time is given to me to make this as a sound, right? Now let us take one of the, can you go for cosine wave? Can you do this for cosine wave? Yeah. Can somebody show me what is the thing for cosine wave? Wave audio 2 is equal to cos, right? Similarly, I would like to put the audio wave, plot it. Now we can plot it, right? It also looks same. And now look at how do you do this, right? Or you do not want to do this, you want to play the audio. Let us play the audio with 10,000. So we'll play the audio with 10,000. Play the audio with 10,000. So it is similar to sine wave because there is no difference between cos wave and sine wave. Only there is a phase difference of 90 degrees between the sine wave and cos wave. Sine 0 is 0, cos 0 is 1. The phase difference is 0 at that point. Cos 90 is 0, sin 90 is 1. At 90, there is a phase difference. But 90-degree angle, there is a phase difference. That's the only thing that is differentiating cos wave and sine wave. Other than that, we can use any of them. That's why you can do the cosine transforms using sine transforms also. But normally we don't do. So it will be cosine transforms only. Right? Are we able to get this? Now, I want you to look from a wave file. How do you import a wave file? For that, you have to install a library called PyDub. I don't know, PyDub may be there, Librosa is there, right? So I've added all of them. Keyboard interrupt. PyDub. I have installed the PyDub here, right? So just go with pip install PyDub in your command prompt. You have to install that PyDub. Now let's look at how can we import the wave file. Now I would like to go with PyDub and I would like to sing the song, right? Or the violin which I sent you, I would like to visualize that. I would like to play that. Now let us start with importing that. I would like to start with import a wave file. Import a wave file, right? From PyDub, import audio segment. Import audio segment, right? Also from PyDub, import play. Play. Now I would like to execute this. PyDub is not there. Let me see PyDub where I can find play. Directory of PyDub. Ooh. Import PyDub. So import PyDub, directory of PyDub. So it will not allow me to check anything else. So I had to look at effects, logging, PyDub. Okay, I had to do this with playback. PyDub playback, PyDub playback, import play. Right now it is working. So I don't need these two. Right. So now I would like to import a song. My song will be my song equal to, it will be audio segment. From this to import a wave file. From wave file I would like to give the directory where I kept this. My directory is da 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 da. This is my directory. So session 1, this is my file, violin original ring. I will take this directory path. I'll give that file name. Let us see what happens, how it looks like. Right. I would like to give this. Right. This is my path. So I'm reading the file now. So my file name is my file name session 1 violin original. Session 1 violin original. One dot wave. So this is the file. Now I read the file. I would like to play this song. Play the song. Can you play the song? Can you see this? Do you have this file? I sent you this file. Do you have this file? Hello?
No, sir, we don't have it.
Don't have it, huh? How come? Okay, my apologies. Okay, you got the file. You can install PyDub, and from PyDub audio segment, import the audio segment from PyDub. From PyDub playback, import play. Then using the song, which is audio segment. From what type of file? From wave file, from underscore mp3, current different types of things. From wave file, give the path, read the file, and then go for playing the file. Play the file. I can play the file. It sings good. Let me see whether I can go for settings. Where are the settings? Device settings, microphone. What do we do? Any idea? I would like to share the sound. I'm not sure. Okay, looks like it's possible now. Tell me whether you can hear the sound I have, but you will get the same sound. Can you hear the sound? Yes, no, not audible.
No, sir, we cannot hear.
Okay, okay. Just check whether it is audible in your own systems, local systems. Able to do this? Yeah, you able to do it? Now let's go for visualizing this audio data, which is the violin signal. So let's visualize the wave file. For doing this, PyDub is not useful because PyDub is mostly for audio processing. But for visualizing and other things, we have to use a library called Wave. So you can pip install Wave. So you can go here and pip install Wave. Right? If you pip install Wave, you can install it. I think I've installed Librosa is done. Pip install mirror evaluation is done. Okay, method done. Keyboard interrupt. Let me check whether I've installed it. Otherwise, if not installed, installed, use pip install wave. Yeah. So let me see whether I can import wave. Import wave. Yeah, I've installed it. So it is available to me. If not installed, you can go for install wave. 1 minute. Some phone is coming. I will attend to that. Bobby, yeah, Sorry for the disturbance. Okay, now I would like to read the data. So the way to read the data, let us look at what is inside wave. So wave contains wave read, wave write is there. So now we will use wave read, right? Let us see whether anything else is there. Open is there. Actually read and open are same, but the read will read it in bytes, open will read it as wave file. Let us use wave open. So read the file as time series, right? So we will call that as the sound is equal to wave open, wave dot open, then the file is here. This is the file. So this is my file. I will copy this file and I will read this file. I will copy this file and I will read this file. Right, the file is read. Now I would like to get the parameters, because all of this will have what are called as the metadata and the data. We would like to see the data and metadata. I would like to see what are the parameters and what parameters it contains, right? For that, let me see what it contains, right? So it says blah blah blah, all those things, all underscored ones are not important for us. Now we are looking at get mark, get markers, get channels, get number of frames, get parameters. These are some of the things which we are interested. First is we will get all the parameters, right? So what are all the parameters that are there? We will get that. Now after that we may use read frames. All the frames that are there, we will read it. So once that is done, we can close it. So we can close and all the data will be available for us for doing the work. Now let us start with, we have parameters. Let us take all parameters and see what parameters are there in our sound, right? Get parameters. So it says that this is one of the things. Basically, this is the one. You can go to wave and check its get parameters, get params, right? That's the one we are looking at. Get parameters, right? Get parameters. So once you execute this, once you execute get parameters, you will get something. And we would like to see what is there in parameters, right? Parameters contains number of channels equal to 1, sample width is equal to 2, frame rate is equal to 44,100, number of frames is equal to 2 lakh, the computation type is none, the compression is not compressed, right? So whether it's the compression type is there, no compression has been done because this is the archive data. As I told you, we will work only with the wave formats which are nothing but archive data, not compressed, right? Now all of this is there. For this, I would like to get this into what we call as n channels, number of channels, right? Let me take this, right? Instead of accessing that with individuals, I would like to go with this, which is called as unpacking in Python, right? I will take this and I will add sample width is this much, right? Then I would like to take frame rate. I will take the frame rate and I will put frame rate, right? Then I would like to go for number of frames, because whether compression is there or not is not important. These are the 4 important parameters I am looking at. I would like to call it as parameters, parameters, params, right? What I want now, I want from the first record to the 4th record, I want all of them. Now you can look at how many channels are there, right? Now we can look at sample width, right? What is sample width? You can print the sample width. You can look at the frame rate. You can look at the frame rate and you can look at number of frames. This is for this violin, right? You can get all of this, which is nothing but the metadata. Now we would like to read this data as a string or as a time series. So I would like to call this as time series, right? Data. Time series of sound is equal to, I want to take sound, read all the frames, read all the frames. It will read all the frames. How many frames it has to read? N frames. It is like read lines in file. Read 5 lines, read lines. When you give nothing, all the things will be read. When you give read for read lines, three will be read. Like that. How many frames you have to read? You have to read the number of frames, N frames. You would like to read N frames, right? Now TS sound, you just look at what is there in TS sound, right? It's all hexadecimal, right? It's all hexa values which you have seen when we saw how exactly it looks like in the wave format from the presentation. It's all hexa. Now we have to convert this hexa to a string data, right? So for this, we will take this TS sound, right? So I would like to call this TS sound as TS data. Now I have to convert this TS sound is equal to time series data, and that will be NP, right? NP dot format string. Format string. What is the data? It is TS sound. This is the data I would like to format. In what way I would like to format? The data type is equal to np dot short, which is nothing but integers. Excuse me. Sorry. This is D type is equal to np dot short. Np dot short. Format string. Where is the error? np from string, not format string. Okay. From string. Right now we got our data in TS data in the time series format. Now we would like to see what is the data shape, right? Let us look at TS data. TS data shape. So what is the shape of the data? So it contains some value, and now we can say that this is equal to what is the shape is. I would like to reshape it. Data shape, right? What shape is equal to -1 comma 2, right? So you shift it. Then I would like to go for TS data. TS data then is equal to TS data dot transpose, right? Now it is transposed. Now it is available as a vertical column. Now what I would like to do, I would like to take this and I would like to get the time for each of them. Time is equal to np dot a range. I would like to get a range, right? Then how many? From 0 to n frames by 2. N frames divided by 2, right? Into 2 divided by frame rate. 2 divided by frame rate. So once we do this, we have the time, we have the data for time series, we can visualize this, right? Now let me visualize what is the length of each of them, right? What is the length of time and what is the length of TS data? Now let us print length of time. Now we know what is the length of time. Also add the length of TS data. Length of TS data. Right? Now we know that it is, oh, it is only 2 minus 2, 2, 2, 2, 2, 2, 2, 2, 2. TS data. TS data T. Okay. Now I will not, I don't need this. So I have 220,500, right? 2.2 lakhs time series and 2.2 lakhs data series. Now I would like to visualize this. I have time series data, and I would like to visualize this. I will put it as plot, right? PLT plot, T plot. I would like to visualize the TS data or time, right? And I want this to be blue. Now you can see this is how my violin is looking like. My violin sound is looking like. Or you can change this. Now it is the vertical fashion. You can change this by changing PLT dot plot time comma TS data, and probably when I change it, it changes to red. You can keep that. This exactly is how it looks like. This is my violin data. Now there are questions which we would like to understand. We would like to slice it, right? There are two ways of slicing it. You try to go for time slicing, or you can go for amplitude slicing. When you go for amplitude slicing, you will not get the flat thing. Now I would like to find where exactly is this. How can I find this? Where exactly is this? This is different, right? This peak is different, right? So I would like to see this peak. How can I do that? Any idea? The thing is, I would like to plot, right, the time with respect to that particular value only. Now let us look at how my data looks like when I take only a slice, right? I will take only part of it, right? We would like to visualize this from, let us say that it is around 50 lakhs, 50,000, maybe around 18,000 to 22,000. Now let us plot this. PLT dot plot time from 18,000 frame to 22,000 frame, right? And we would like to plot the TS data. TS data is also from 18,000 frame to 22,000 frame. We can see this. This is how my peak looks like. This is my peak. Now you can see there are multiple frequencies that have been added here. Can you see this? Right? It's not just one frequency, multiple frequencies which needs decomposition. Yeah. Can you work with this? Similarly, you can see, I would like to see this portion. I would like to see from here to here, from 5,000 to maybe around 7,000, or 50,000 to 70,000. So let me see PLT dot plot time from 50,000 to 80,000, and TS sound, TS data, time series data from 50,000 to 80,000, right? Now let us call this as red, right? Color is red, right? Now you can see this how this portion looks like. So this how from here to here the portion looks like, from 50 to around 80. Now let us bring it down to around 70, not 80. Let us bring it down to 70. Right? This is how my data looks like. Starting from here, starting from 50 somewhere here, it is moving up to 70. This is how my data looks like when I enlarge it. Now I had to window everything and use that and try to see what belongs to which window, how they look like, and that can be done with k-means. I will not do k-means today, but I want you to get comfortable with this. How do we get the data? Because our idea is to get this time series data. Then we will go for MFCC and other features which can be extracted. Yeah. So just see, let me share this sheet with you. I want you to work with this. In fact, I prefer you type it than use it. Anyway, I will share the file. I will share it as HTML instead of Python notebook because it is too heavy. Untitled. Okay. Visualizing the sound data. Visualizing the sound data. That itself is 2 MB. My God. Yeah. Okay. Just see whether you can visualize the data, whether you can play the data. Right? Were you able to play the data? Any problem? Da, 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 da. If somebody can show the screen that, oh my God. Untitled. Okay. If you are in doubt, go to the Python wave documentation. Go there and you can check, read and write wave files, and you get all the details, all examples, everything will be available here. As far as possible, go with documentation only because it is much easier. So you can read and write the sine waveform that we have produced can be written to a file using wave, but I won't do that because most of the time we don't do it. Right. Similarly, you can go with PyDub. Documentation. So everything is available. Audio segmentation in PyDub. Right. You can go to PyDub and see all of that. Whatever you have done now is available in and they have taken Keras and built the models and all those things, which is good. We'll come to this. We'll make Fourier transforms of whatever we have. You get this also. Similarly, you can look at documentation of librosa. Librosa is a DSP package for Python for audio analysis. Right, you can go to documentation. So these are the three which we are using. PyDub, librosa and Wave are the three files we are using. You can check the documentation and the corresponding examples and you can see that. So at the end of the day, our expectation is, can I get the features from the audio file? Frame rate, number of samples that are there, frame length, the file length and all those things. Can I get those features? Using those features, can I do some additional things? Either I can go with the energy of mel frequency and things like that, or I can get additional metadata and try to combine both, right? That is what is given, like what exactly they are trying to do. For example, they are trying to do machine learning here. Is it a speech, music, or birds? What they have taken is, they have taken MFC features, the GFCC features, combination of these two, and they are checking which is good. They feel that GFCC plus MFCC, most of them are correctly classified. Only birds, sometimes they sing like speech, sometimes they look like music. It is unable to do that. It's very clearly, it has been classified. Yeah. So this is what we are going to do in the subsequent sessions. We'll start with taking the data, then converting into MFCC, then trying to build the model and trying to test that whether it classifies correctly or not. For a variety of things, it can be unsupervised or it can be supervised. Yeah. Please go ahead and see that. Done. Any problem? Batch has become so silent. Prem, are you there? No, audible. Hello, Niran?
Yes, sir.
Am I audible?
Yes, sir, you're audible, sir.
Ah, is Prem there? He is visible.
I think he might have some audio issues.
He's not speaking even. Oh, he belongs to our category. Keep it on and go out. Prem Kumar. Guru, where is your presentation?
Hello.
Ye- yes. What is the
Yeah.
use case you selected? Where is your presentation?
Yes, sir. I selected this one, sir. Reducing employee efforts, sir.
Reducing employee efforts.
Yeah.
What will you do there?
Shall I share my screen, sir?
Yeah. You can share.
Yeah.
Mm-hmm.
Yeah. We know, right, and customer support, right? When we get a call from the customer, no, the executive has to do a multiple tasks, right, including logging the call and give some sort of resolution till the resolution, right? He has to do multiple tasks. In between, if there are any uh, issues, right, like page is not loading, system slow. So this one will for the employee, right, the frustrate all these things, right? So all this we can easily get it from by audio analysis, from getting the insight from that audio call.
How? If he's not speaking, how do you get that page is not loading by audio analysis?
That audio, that the words will be there, right, like this one, huh?
No, if he speaks, he will have that. If it is not working, he leaves and goes. And how do you know he's speaking?
No, all the issues we will be speak, right, with the customer are is
You mean to say the
related.
client will speak to the customer service executive?
Yes.
Okay. Okay.
While resolving that, the employee also can face these issues, right? My system is slow, please hold on, right? Running slow, we can't do anything. These are actually all the pain points for the employees, right? To resolve an issue. So this kind of an words we can easily get it, right, from the insights by applying the sentiment analysis, na? By identifying the
No,
pain point.
do you need sentiment analysis for that? Why do you need sentiment analysis for that?
Now, how do you get this kind of an statements, right?
They are statements. It is speech to text conversion and labeling.
Yeah.
Somebody has to label it. It is not sentiment. It actually named entity recognition. You convert that into speech to text recognition. I mean, speech to text conversion. Then you will go for named entity recognition with relation.
Okay.
So my X is not working. My refrigerator is not working. My TV is not working. My system is not working. My mouse is not working. X is not working. It's a named entity recognition, right?
Yes. No,
So
here we are focusing on the employees' issues rather than the customer.
oh yes,
Because
employee does not know what to tell. In that case, you will try to give the guidance to the employee what to speak.
yeah.
But basically, you would like to understand what the question, right? So the question has to be first translated into text.
Yes.
And then that text has to be matched with the previous text where the employee has successfully answered and it has been resolved.
Yeah.
The
Okay.
moment somebody listens to the question and converts that into the text, I have to give the feedback to the CSR that this is the answer for this question. Then there are two things that are likely to happen. A low qualified person can become a CSR. He need not have to be domain expert to answer such questions. Because system may give 80 to 90% of the answers to all these questions. He has to ensure that his skill need not to be very high. That's one of the advantages. The second is, what are the most likely questions that are to be asked by the clients to the employees, and how the employee has to answer, which will be taken up by training, which will be taken up by other things, can be done here. So that's what you have to look at. And what is your system design? How do you design? These are all objectives.
Yes. No, basically we are more focusing on the employees issues rather than the customer issues, right? Because if employee facing the issues, right, like complexity in the screens or the steps process,
That,
right?
that he will call the systems guy. Why he has to set his own system?
No, from this one, because otherwise if this system is not working, right, he has to do a workaround solutions, right? That will take more effort, then will lead to a
Not
frustration
sure.
to the employee.
It will not fly with me when you say that I will reduce the employee effort by speaking. Right?
No,
It
no,
will not.
these are the pain points. No? That those things we can be identify, right, in the audio. I mean, when we convert audio into a text, na, then we can apply.
That's why I asked you. You are expecting employee to speak.
Yes, definitely they will something. He has to engage the
They will
call,
raise a
right?
ticket. They will raise a ticket with service now.
Okay.
They will not
Yeah.
speak. Then what will you do? For me, it has nothing to do with employee facing problems in serving the client. Employee facing problem in serving the client with the knowledge is the problem.
Mm-hmm.
right? So he may not first call resolution is not happening. That is the problem. Why it is not happening? That you have to identify.
Okay.
Right? This basically is employee effort means now he is taking 20 minutes to answer this question. Can I reduce it to 2 minutes?
Yeah.
Right?
To
That
reduce
is
the
effort.
to reduce that thing, right? We need to identify what are the issues, right?
It may
So
not
we
be his screen not working. His
mm,
screen is working, everything is there, but he is searching for 5 problems. He says your screen problem is maybe due to the screen lighting that is there, and he checks the lighting, everything is okay. He should have checked what is the most important problem that is there, isn't it?
okay.
You have to be very careful because now if you are proposing this system, you may have to sell this system to somebody.
Okay.
They'll put money, right?
Hmm.
Unless there is customer, how can I put money into the product? I
Hmm.
cannot put my money, right? But what is the system that you are developing? What components are there? How they talk to each other?
Yeah. Actually, these are the steps. Actually, I was thought about.
I
As-
cannot read. What is it? It looks like the same one. No, these are yeah. This
Yeah.
exactly. You had to do this.
Yeah.
Right. And you are telling speech to text, sentiment analysis, recommendation system, AI, monitoring. What is the difference between AI, speech to text, sentiment analysis, recommendation system?
Now, the first one, it has to convert audio into text.
Is it AI
Then,
or not AI?
no, this is not AI. I mean, for this first step, na, getting insight from the audio call, na, we need to apply this technique, speech to
No, no,
text.
is speech to text artificial intelligence component or not?
Yes, it's a artificial intelligence only
Then what is the other artificial intelligence you have there?
to automate the process. Actually, that's the reason. For the first step, na, to
No,
automate this step, we
no,
need
no.
AI.
There is no clarity. It looks like you have hodgepodged it. You have to clean it up.
Okay.
Right. The first three are okay. Right. If you want to do monitoring, then you say give insights, then you say you do monitoring. I'm not clear.
Now, monitoring in the sense, here we need to, once we automate the process, right? We need to monitor how it is that the AI the process is working, right? So that we can make it better system, na, for the recommendation system.
You tell me what is this AI?
Something, say for the process, right? He has to go to multiple pages. So instead of that, the system can suggest something, right? Like
But then what
the
is
what is
recommendation system?
recommendations. This one will just what are the action use that employee can take to resolve that issue. So this one, that
I
issue we
have
can automate.
my differences with you. Hmm? Sorry?
Now after recommend he's choose that recommended select option, right? Then this AI will automatically do that process.
That is RPA. It has nothing to do with AI. It's a part of AI. Speech to
Oh,
text is AI. Sentiment analysis is AI. Recommendation system is AI. RPA is AI.
okay. Yeah.
That's why I'm looking at what exactly is AI in that.
Mm,
Both look like reducing system solution. What flows from where? So you know in the above slide.
huh.
So you say speech to text.
Yeah, correct.
Who speech to text? Employee speech to text. Client and employee speech to text. Whose speech to text you are trying to take there?
No, for all audio calls, sir, because we need to get insights, right? How will you get this one, sir? Uh, I mean, the pain points. Now we need to do a sentiment analysis, right? Before that, we need to convert audio file into text, right?
Okay. Now, which audio file? Both employees as well as the clients?
Yes,
Where is that?
it's available, right? Anyway, the audio file.
Okay, you cannot assume that is not a system. It is like I'm giving this box, believe this.
Okay.
Right. You have to show the interfaces. Where what is the interface, how it does. Okay, that's okay.
Okay.
ಇನ್ನು ಇಷ್ಟೊತ್ತಿಗೆ ಯಾಕೆ? Not now. Okay. Okay. That's okay. You have to define it.
Okay.
Okay. Okay. Suresh, what about you?
Yes. Let me share my screen.
5:30 6 ಮಾಡ್ಬೇಕು ಇಷ್ಟು ಬೇಗ ಮಾಡಬಾರ್ದು ನೋಡಿ ಇನ್ನು ಸೂರ್ಯ ಮುಳುಗ್ತಿಲ್ಲ ಕಣ
Don't have an option to share.
Niran, can Suresh share?
Yes, sir.
Suresh share his screen. He's sharing, I think.
Niran, I don't have it, Niran.
Let me check, Suresh.
Oh, is this Niran? I thought it is Suresh screen. Or it is Guru's screen.
Frame, you have to stop.
It is Guru's screen, sir.
Oh,
Suresh,
okay.
I think you have the permission. Can you just try once again?
Yeah. Can you?
Yeah.
Yeah, similarly, predict the best possible solution for the customer care issue, whatever Guru or Prem was talking about. The similar way where customer talks to the, to the customer care services, where from the speech to text has been converted. From text, we have a different, NLP text mining model. What is the best possible solution we can able to come up with a different ML solutions, from data cleansing, data collection, data mining, everything. Then we get different statistic or modeling or deployment, and from there I didn't started it and few solutions like whatever we're talking speech to text, sentimental analysis, and recommendation. I need to add it up.
Okay, I'm not getting the difference between data mining, predictive techniques, modeling and algorithm building, statistics. Too many hodgepodge things have been connected.
Yeah. I can make it as one. Yes, I can remove and
Now,
make it
what
as three.
exactly you will do? You will take the customer service call records or customer service discussions. You will transcribe it. Then what will you do?
Yes. Then once we get into text data, then we'll cleanse the data, collect the data, all the statistical modeling I build up. Then I
No,
build
no,
up the
no. You
model,
have to be very,
text
very
mining.
specific. What exactly you do? Will you build a recommendation system?
Yes, I kind of build a
Then
recommendation
why do you
systems.
need predictive analytics, statistics, modeling, data mining? All those things are why it is required.
It's a part of a modeling, right? Even
Yeah,
though
what is
recommendation
NLP, data
systems.
collection, cleansing, data mining? What NLP is doing then?
It's a part of NLP is nothing, or text mining is not. It's a part of a NLP only, right? So I'm deep driving into all the details.
No. NLP is not part of text mining. Text mining, NLP is
Yeah,
part of
text
text
mining is a
mining,
part
not
of NLP.
yeah. Okay, so text mining, data mining are two different things because data mining is part of text mining.
Yeah.
Then what is predictive techniques?
We're going to predict whenever the customer calls up, right? We next time, whenever he calls up, when we build the model, right? We're going to predict what is the customer sentimental analysis is going to do, is positive or negative, is talking about the product. So based on the text, whatever he's talking about, we can predict, the customer is talking about, positive or negative based on the the voice is coming up
Yeah,
whenever you're converting from the.
what is model building?
We build up the model based on the text.
No, it is too confusing. Too many things jumbled, and it's most of them are redundant.
Yeah.
So if you say data collection, data cleansing, data mining, right? Only that much can be NLP, but subsequently deployment can be part of NLP, right? But
Okay.
where exactly you bring modeling algorithm, all those things is data mining for me.
Yes.
Right? Your data pre-processing cleansing is tokenization, stemming, starport removal, and other things is data cleansing. Right? Your modeling statistics is data mining and deployment. So why do you bring content identification? Why do you confuse between apply predictive analytics, statistics, modeling algorithm? Too confusing.
So I'll make it remove that and keep it only ML algorithm rather than statistics and all.
That's okay. Whether it is statistics, ML, or artificial general intelligence, AI, doesn't matter. So what we are looking at is there must be some audio component in your system. That is the requirement.
Yes.
And subsequently, your system becomes too complex because of tail heavy thing. You cannot move, right? Body should be, systematically strong. And neither the head strong nor the tail strong is not good, isn't it? Doing
Yeah.
everything in the database or doing everything in the AI is not good. It must be equally spaced out. Okay, this has to be modified and you have to say what exactly you do in each case, right? What you do
Sure.
in NLP and text mining model? Are you doing speech to text conversion, or what are you trying to do? We are not clear.
Yeah, I mean, I'm going to make a no. I'm converting my speech to text here. In a no.
But it is not coming anywhere.
No, I'm just want to. I mean, I just started it. I'll update it.
Okay, who else is pending? Bhardwaj just done. Guru, Pavan, Prem. Prem, are you there?
Yes, sir.
Oh, good. Finally, we caught you. Okay. So, what's your proposal?
Sir, I am doing on this one, video to text generation. Sir.
Video to text. Which
Yes,
is the
sir.
use case? Can you tell me number, use case number?
Use case number in that I think it is not there, sir.
No, there must be some use case, right? I had given the readings. Which is the use case? Video to text. No, video
Text generation, sir.
case number is there. Case number. Can you tell me what is the case number? Why do you want to do video to text? I can understand audio to text, but how do you do video to text?
That video will have the audio also, no, sir.
That is audio to text only. That is transcription. But
Yes, sir.
what will you
That
do?
language generation. Language they can convert to other languages.
Translation.
The translations.
So how will you do it? What is your system? How it looks like? Don't worry, you have to write it in hand and show it. That is okay. Right. The idea here is to remove your fear of not doing it or doing it wrongly. That is okay. Do you think I do it correctly? Right. You should never assume that. The only thing is I learn from my mistakes. Commit the
Yes.
mistake quick.
First, we will be reading this audio, sir, and then we'll asking for the conversion, which language they can convert.
No, you just don't complicate it. You try to say you would like to convert from Kannada to Tamil or Kannada to English.
Yes, sir. Yes.
Right? And English to Kannada. It can be only one way.
Yes,
Right?
sir. It's
So
like a
your
subtitle, sir.
audio translation on only one side is not okay. But text translation to one side is okay. From Chinese, I want it in English, it is okay. Right?
Yes, sir.
But this will be
Yeah.
a communication system. So you must do always a two-way translation. Right, how will you do that? Can you do it for some 10 phrases? 10 sentences.
Yes, sir.
Okay, I would like to see that. You will have 10 sentences, maybe 5 questions, 5 answers. So you ask questions in Kannada, the other person answers in English, and that English answer is translated to Kannada, and you will speak back in Kannada.
Okay, I was thinking of, on one side, right? Two way we had to do the
Translation.
similar.
It's a text problem, not an audio problem.
Okay, sir.
It is not an audio problem. Audio problem will be this. You take an audio, convert that into text in one language, translate that into another language, find the question, find the answer, then convert that answer into the original language, then speak back. Yeah.
Okay, sir.
So
Yeah.
you need not have to speak in English. You have to
Okay, sir.
find the answer in English and speak back in Kannada, because
Okay.
your query results will be in English, not in Kannada. But your questions are asked in Kannada.
Okay, sir. Here we have to convert the questions in this one language, whatever they select Kannada. Then
No, English. No,
get the
you
answer again
fix it.
convert
You
back to
fix it.
English.
They will ask the questions in Kannada. First, it has to be tracked in Kannada. Then it has to be converted to English. From English, you have to find the answer. Then translate that back to Kannada and speak back Kannada. If Kannada is difficult, make it as English. They will ask question in English. It will be translated to Kannada. Kannada person will answer it. System will take that answer, translate it to English, and then speak back in English.
Okay, sir.
Yeah, just do it for 10 sentences. We will see how well it is working.
Okay, sir.
Okay, anybody else? I would like all of you to submit this system design and what modules you are going to use, whether it is a audio analytics module, text analytics module, or a hybrid analytics module at each level or each node of analysis, what you are trying to use, and please share that so that we can continue that once we start building machine learning models. We'll build a lot more models, and one of the models, a couple of models you can use as a part of the program. But you have to bring your text analytics, translation, and other skills to this. That's very important now. Okay. So we'll connect again next week. We will work on a couple of modeling techniques. One will be how do we take the audio data like what we have taken now. Now we have just built a time series model or visualized the time series. And now we would, because there is no prediction in sound. I cannot predict whether he is likely to say yes or no using sound. Right? It is mostly identify what sound it is. In fact, if you can see one of the programs that's currently running from Government of Telangana for Department of Forest, it basically is based on the sound. Can you detect which animal, whether it's a poacher or it's an animal or it's a bird that is likely to be there? A very solid case is there. Right? So that kind of problem where we would like to classify the sound as a music or a speech, we would like to take that up using machine learning. Then we would like to do some kind of segmentation, how exactly we can do that. Then we try to go for maybe can we detect some kind of voice command, right? Those are the problems that we try to solve next week. Right? We try to pre-process all the data. Once the data is in standard format, apply regular techniques like SVM, random forest, deep learning, all those things. We will try to see that. Okay. Sure. Please take a look at that Alan Downey's book, Think DSP. That gives a lot more information than what we discussed today. What we had done is just tip of the iceberg. So read the book and implement the book, some of the exercises and things like that. You will understand better how exactly we are doing audio analysis. But it stops at analysis. It will not come to ML. We are starting from where they stop. We take part of what they are doing, what that book teaches, right? Specifically extracting the features. But after feature extraction, what will you do? You have to build a predictive model, like classification model. So that is what we try to do here. Yeah. Okay. So we'll connect again next week. Have a good weekend. Okay.
Thank you, sir.
Niran, please collect the basic presentations. We'll improve upon it next week.
Sure, sir, I'll do that.
Okay. Thank you, team.
Thank you,
Thank
sir.
Thank you, sir.
Thank
Thank
you.
you, everyone.